Okay. Okay. In the heat equation, we have seen two kinds of heat equation. So heat equation, the equation is this: ut is equal to alpha squared uxx, right? X between 0 and L, and then T positive. And then we have, let's say, some boundary conditions, homogeneous or non-homogeneous. Okay, let me say homogeneous ones. LT, and then we have initial condition, right? And in this case, what is the solution? UXT, right? We can just write down the solution, right? It is just n from 1 to infinity, bn e to the power minus n pi alpha over L squared T sine n pi x over L. Öyle ki where bn is just 2 over L, değil mi? 0 to L f of x sine n pi x over L dx. We know how to solve this equation and also this one. I guess this is what you have seen, the next one in the recitation. So ut is the same equation, but the boundary conditions are. So in this case, boundary conditions are, let's say, kept 0, like this one, right? So you have a metal bar. It has some initial temperature distribution, but then you keep the endpoints at 0 degrees Celsius, and then you let time go on, and then of course the temperature will eventually go to 0 because the ends are always at 0 degrees. And from the solution also, you know that the solution will go to 0 because st goes to infinity. So let me write it here. This note that uxt goes to 0 as t goes to infinity. This is of course expected, which is expected since there is no external heat source, and the ends of the bar are kept at 0 degrees Celsius, right, at that temperature. Therefore, we expect that the solution goes to 0 as t goes to infinity. The second kind of equation is this. You have the same equation, but this time the boundaries have this form: u sub x 0 t equals 0, u sub x lt equals 0 for positive T, and you have initial temperature distribution, f of x. This means what? The temperature at the end points, right, doesn't change in the x direction. When I mean we had or when would there would be heat conduction, if there is a temperature difference, then there would be heat conduction. So in this case, this derivative is 0, means there is no temperature difference between these 2 points, and therefore there is no heat conduction. Actually, this condition means that the ends, both ends, are insulated, so there is no heat transfer at the ends. Okay, so there is no, so these are insulated. Let me just denote it like this. So the ends, the conditions and u sub x lt are equal to 0 for all t, means the ends means that the ends of the bar are insulated, so that there is no heat transfer or conduction at the ends. Bu durumda çözüm ne oluyordu? Değil mi? If you just go over all the steps, this time you see that sine terms will vanish. There will be only cosine terms left. So in this case, solution uxt, it's similar to this one, but instead of sine functions, we have cosine. So we will have like this, and we know that you have to write the first term separately, a0 over 2 plus n from 1 to infinity, an, and then the same thing, okay, minus n pi alpha over L squared t, this time cosine n pi x over L, and all these an's, including this one, are just, again, the same thing, integral from 0 to L, initial temperature distribution times cosine n pi x over L dx. Okay. Biliyorsanız, yani sınıfta yapıldıysa kabul edebilirsiniz. Ama eğer size söylenirse yapın diye yapacaksınız. Tamam mı? Evet, söylenmezse doğrudan çözümü yazabilirsiniz. Yani sınıfta yaptık çünkü. Tamam mı? Yani bir daha yazmak zorunda değilsiniz. So, since we have done all this in the class, you don't have to, go all the steps to write down the solution. You can just write down the solution, okay? Like I did over here. You don't have to derive the solution. Okay, now there's a third kind of equation. I'll just talk about that in the first hour. Hangisinde? Ya onlarda da ne yapacağımızı biliyoruz ama yani hani işte bir tane evet evet evet aynen. Orada bir farklılık yok. Farklı bir problem şu olabilir. Uh, okay, now we will consider mixed boundary conditions. Robin mi oluyordu? İşte tamam neyse. PDC olmadığım için o isimleri öğrenemiyorum. So the same equation ut is equal to uxx x between 0 and L and t is positive and the boundary conditions are mixed. So what I mean, one and let's say like this, a condition on u and the second and is a condition like this. So here I don't have derivative, here I have derivative, okay? So this means what? One and we have also, of course, this initial temperature distribution. So this means what? At this end, the temperature is kept as 0, but this end is insulated. This end is not insulated, okay? Yani buraya işte bir büyük buz kalıbı koyuyorsunuz. Hep 0 derecede kalıyor. Ama burası işte insulated olmuş. Yani buradan ısı transferi olmuyor. Tamam mı? Mesela bir önceki örnekte hiç ısı transferi olmadığı için toplam ısı hiç değişmiyor orada. Hep aynı. Isı böyle gidip geliyor vesaire. En sonunda tabii duracak. 10 yıl sonra gelirseniz değil mi? Constant bir temperature'da kalacak. Burada öyle değil ama bir ucu 0 olduğu için bu 0'a inecek. Ama nasıl? So in this case, there is this end is not insulated. Therefore, we know this. Ux t will go to 0 as t goes to infinity. Because there is no heat source. There is no heat source. And there is this condition. And it will force that as time passes, the temperature will go to 0. But what is the solution? So here, I'll just go through all the steps, okay? So solution. Burada hani bunu doğrudan fiziki yorumundan dolayı yazıyorum. Değil mi? İnanmıyorsanız hani işte elinizi bir soğuk suya sokup bekleyin. Evet, sonsuza kadar. Tabii orada iç ısı var ama yemek yemezseniz bir süre sonra o ısı da yok olacak. Evet, sonra. Efendim? Nasıl? Ha, şurada u sub x de mi olsaydı? Ha ama o şöyle diyorsun, öyle mi? E, Bu şu demek ama yani hiç ısı transferi yok. Pardon, hiç ısı transferi yok orada ve bu burayı 0 derece tutuyorum. Bunu yapamazsın. 0 derece nasıl tutacaksın orayı? Ya orayı soğutman lazım. 0 dereceye indirmen lazım. O yüzden hani ısı transferi olması lazım. Yani bu ikisi birbiriyle tutarsız. Tamam mı? Yok, burayı silecektim. Pardon. Hı? Oda sıcaklığı değil ama bu şey. Yani şöyle, şuralardan hiç ısı transferi zaten yok. Onu kabul ediyorum. Ama burada da olmasın. Yani şuralarda da zaten ısı transferi olmadığını kabul ediyorum. Sadece şurada var. Yok, bence tutarsız. Yani sıfır olmak zorunda değil ki o. Oranın sıcaklığı değişir yani. Okay, so let's see how we can solve this equation. So we just write down, as usual, our differential equation, and we look for solutions of this type, right? U x t, x of x, and t of t, right? So separation of variable technique. We just take derivatives. U sub x is just x prime t, U sub x double prime t, and U sub t is just x t prime. We just plug them into the equation. This is alpha squared. So we get alpha squared U sub x. It is just x double prime times t, and that's equal to U sub t. So it is x times t prime. And then we write this as x double prime over x, and then t prime over alpha squared t. And then we proceed as follows. X is a function of t, therefore this side is a function of, x only, and this is a function of t only, and x and t are independent variables, meaning that I can keep x fixed and vary t. In that case, this will not change. This may change, but since they're equal, this won't change either. Therefore, we conclude that both of them are just constant functions. And we say that, this constant function is, let's say, minus lambda. Okay? Değil mi? Aynı şey. Burası x'in fonksiyonu, buranın t'nin fonksiyonu, ama x ile t'nin birbirinden haberi yok. Yani dolayısıyla her ikisi de sabit olmalı. Değil mi? Yani iki arkadaş var ama birbirlerinden haberleri yok. Biri bir yere gidiyor, diğeri başka yere gidiyor. Ama ikisi de aynı yerde kalıyor. Öyle bir garip durum var yani. Okay. And then we just, as usual, write down two equations. One of them is this, and the other one is just t prime minus, no, plus lambda alpha squared t equals 0, right? So from this one, x double prime over x is equal to minus lambda. So x double prime is equal to minus lambda times x. I collect all the terms on one side, so I get this equation. All right, now let's concentrate on this one. Its characteristic equation, right, is what? It is just r squared plus lambda is equal to 0. So we have cases as usual. First, let's see case 1. Alpha is, let's say, negative olsun. So this means r squared is minus lambda, which is positive. Therefore, R1 and 2, right, the solutions are plus minus these numbers. This is the real number. This is a real number. And therefore, and it is not 0, we have two real roots. Therefore, the solution is e to the power let's say R1 x plus C2 e to the power R2x. Söyle. Yani mesela ben şimdi ne çıkacağını bilmediğim için yapmak zorundayım. Biliyorsan yapmak zorunda değilsin ama bilmiyorsan, yani sınıfta yapmadığımız bir şeyse olmaz. Evet. Sadece benim okumam zorlaşır. O da kafam atar. Kötü not verebilirim. Yani o yüzden böyle çok egzantrik şeyler yazmayın. Tamam, tamam. Doğru yaptığınız sürece sorun yok. Sor. Ee, ikinci derece olanları çözeriz herhalde. Evet, evet. Yani çözemeyeceğimiz bir şey olabilir mi? Yani variable coefficient'ları da yaptık ama o bilmiyorum, hani orada incelemediğimiz durumlar var mı? Çok emin değilim. Okey. Şimdi ne yapacağız? Condition'lara bakacağız, değil mi? U0 t equals 0. Bu neydi? Bu 0. So this is x of 0 times t of t equals 0. Well, if this is not 0, right? If this is not 0, so if x of 0 is not 0, then t of t as a function would be 0, and hence uxt as a function would be just 0. But, of course, u equals 0 is a solution of this problem, right? It solves this problem. It satisfies this differential equation, and it satisfies both conditions, but it will not satisfy this one. Therefore, we are not interested in the 0 solution because it will not solve the initial value problem. Therefore, we will not assume that this is not 0. Hence, thus, we will let x of 0 equals 0. Yani işe yarar bir çözüm istiyorsak bunun sıfır olduğunu kabul etmemiz lazım. Daha doğrusu şöyle, x sıfırın sıfır olduğu çözümlere bakmamız lazım. Diğer türlü sıfır elde ediyorsunuz, right? So we have to just look for solutions where x is 0 at 0, otherwise you get just the 0 solution. And that's not interesting. So we have this condition. What about the second condition? U x0 t equals L. Şurası L olacak. Özür dilerim. Bu zero'ydu. So this means what? X prime L times t of t is 0. And the same thing is true. If this is not 0, then this would be 0, and so on. Similarly, we let x prime L equals 0. So you see, this time the boundary conditions on x are kind of different, right? Here, the value at 0 is 0, but here, the derivative the value at 0 is 0, and here, the derivative at L is 0. Okay, so let's see what we get. Okay, şimdi okay. İşte ben nasıl almıştım? Ha, e, şu başıma iş açar mı diye. Ee, efendim? X'e göre. X one variable fonksiyon ya. Ya şurada bir değişiklik yapayım da şimdi emin değilim. Notlarda ki sorudan farklı bir şey yazmışım. Hani çok karışırsa farklı bir şey olmasın. Let me just change this derivative with this one. So this end is insulated and this end has temperature 0. Okay. So this will change what? This will change what? Bu L'de 0 değil mi? Şöyle L. Eğer bu 0 değilse bu olacak. Bu 0 olacak. Dolayısıyla bunu 0 kabul edeceğim. And then 0 t is 0 0 0. Okay, so let me just do it this way. Okay, now okay, we have a solution of this type. X of x is just c1 times e to the power r1x plus c2 times e to the power r2x. And we have what? Neydi? X of L is 0 ve X of L is 0. So when I plug L, I should get 0. Well, ya da ilk önce öbüründen mi başlayalım? Kim? X prime. Neyse fark etmez herhalde. L yazdığımda 0 olacak. Bu C1 E üzeri R1 L artı C2 E üzeri R2 L eşittir 0. Okey. Eşit çıkacak mı? Emin değilim. Bakayım. Ha, evet. So C1 e to the power R1x. This is, so when you take derivative C1 plus C2 R2 e to the power R2x, but R2 is just minus R1, right? So this is C1 R1 e to the power R1x minus C2 R1 e to the power minus R1x. Okay. And this is 0, right? All right, so we get what? R1 times bir dakika. R1 parantez. Ha, x yerine 0 koyuyoruz. Tamam. So C1 R1 minus C2 R1 is equal to 0. So R1 C1 minus C2 is 0. So either I will let R1 equals 0. Okay, R1 is positive or negative. R1 was negative. No, positive. Sorry. It's positive. Therefore, we get C1 equals C2. All right. So X of X is like this. C1 equals C2, and then e to the power R1x plus e to the power minus R1x, right? Because R2 is the same as minus R2. So we have this, okay? Diğer condition neydi? X of L is 0. So C1 e to the power R1L minus e to the power minus R1L. Well, okay, this is a, actually, yeah, I don't have to do anything. This is the positive number, e to the power, anything is positive. This is also positive, positive. This is 0, therefore we get C1 is 0, therefore C2 is 0. So we get just the 0 solution, nothing else. Okay, so we have to consider the other case. Nedir diye other case? Case 2, lambda is 0. In that case, we have the characteristic equation r squared is 0. So r1 and 2 are both 0. So we have x of x is just c1 e to the power 0 x plus c2 x times e to the power 0 x. So we get just c1 plus c2x, right? What about the conditions? X prime x is just c2, right? X derivative is just c2. So 0 equals x prime 0. Well, we get c2 is 0. So x of x is just c1 constant, right? And x of L is also 0, implies C1 is also 0. So again, we get just the 0 solution. So we don't get anything from this case either. Case 3, lambda is positive. In that case, characteristic equation is this. Therefore, this is negative. So let me just write it this way. This is minus mu squared. Okay. So R is just plus minus I times mu. Therefore, we get solution x of x is just C1 cosine mu x plus C2 sine mu x. Okay. I need the derivative, so it is just minus nu times C1 sine mu x plus mu times C2 cosine mu x. Okay. We will compute this at 0. Okay. Okay. Now 0 equals x of 0, x prime 0. 0 koyarsak oradan elde ederiz. Mu C2 cosine 0, which is just 1. So we get this. Mu is not 0, of course. Therefore, we see that C2 is 0. Therefore, x of x is just C1 times cosine mu x. What about the other condition? X of L should be 0. When I plug it here, we get C1 times cosine mu L is 0. If this real number is not 0, then C1 would be 0. Therefore, we would get x equals 0, right? So if to get, let me write it this way, to get non-zero solutions, we must take cosine mu L equals 0. Şimdi bakalım cosine mu L, yani mu sayısı, so this real number mu should be so that cosine of mu L is 0. Well, that means what? Mu L, hence mu L should be what? So cosine is 0 at odd multiples of pi over 2, right? It is 0 at pi over 2, 3 pi over 2, 5 pi over 2, and so on. So that's an odd multiple, 2k minus 1 times pi over 2. K is an integer, right? It should be like this. Not multiples of pi over 2, because 0 is a multiple of pi over 2 and cosine is not 0 there. It's an odd, it should be an odd multiple of pi over 2. Okay, so we get what? Hence, x of okay, her bir integer için bir tane var, n diyelim ona. X of x should be like this. Cosine 2n minus 1 pi over 2 bir dakika. Yok, mu x L, tamam, L'e böleceğiz, x şöyle. Tamam. Cosine mu bir de 2 var. Okay. For any integer, we should have something like this. As before, you know, negative ones will not count, because, you know, if you choose negative integers, cosine will absorb them. So it is enough to just let n take positive values. So we may just take xn of x to be cosine 2n minus 1 pi x over 2l, and n is 1, 2, and so on. Değil mi? Eksi 1 yazarsanız eksi pi bölü 2 olacak, ama kosinüs eksi pi x bölü 2 ile kosinüs artı işte pi x bölü 2 ile aynı. Çünkü kosinüs x'in önündeki negatifi görmüyor. Neyi 2 ile çarpmıyoruz? Her integer için bir tane çözümüm var, ama negatif n sayıları için elde ettiğim çözümlerle pozitiflerle elde ettiğim çözümler aynı. Tamam mı? Sadece bunlar var. O halde u'yu bulmadık. What about tn of t? Right? Efendim? Yok. T'ni de bulmamız lazım. Değil mi? Şöyle mi? Aha. Zamanın var mı? 4 dakika. İyi, şu T'ni de yazarız. Ondan sonra da şey yaparız. Fourier kısmını. Yani bunu da ezberleyeceğiz de çözümü çözümü bilmiyoruz ki. Okay. Now for t we have this equation, right? As usual, and then from this we get t and t e to the power minus lambda alpha squared t, and lambda is just mu squared, right? And mu is just mu n, and it is neydi o da? 2n minus 1 pi over 2 şöyleydi. Tamam. Bunun karesini alacağım. O halde şu. Yani e üzeri eksi 2n eksi 1 çarpı pi, alfa da var. Bölü L de var. Değil mi? 2L. Bunun karesi T. O halde un x t is just what? Un x t is x of n times t of, so this is t and t times x and x, and from 1 to and so on. So we get, okay. Yani ne oldu? E üzeri eksi 2n eksi 1 pi alfa bölü 2l'nin karesi t kosinüs 2n eksi 1 pi x over 2l. Therefore, the general solution has this form. So, and from 1 to infinity, just some coefficient, let's say an e to the power minus, ya da cn diyeyim de şimdi karışmasın. Cn 2n minus 1 pi alpha over 2l squared p cosine 2n minus 1 pi x over 2l. Peki şey neydi? Initial condition'ımız, initial condition f of x equals u x 0. I let t equal 0. So when you let t equal 0, this term will just give me 1. So n from 1 to infinity, cn, and then cosine 2n minus 1 pi x over 2l. So it's another Fourier series, but this is not something we have seen so far. It is not sine series, it is not cosine series. It is cosine, but I have only odd terms, and I have some kind, it's a strange kind of function. So it is not usual Fourier series. where the functions would be cosine n pi x over L or sine n pi x over L. This is something different. I will show you in the second hour how to determine the CNs. Okay, so let's see that in the second hour. Şey